Hi guys, let us understand one instruction which is very important from the exam point of view, which is DAA. Now what DAA stands for? It stands for decimal adjust after addition. So this is a D, this is A and this is A. Makes it DAA instruction. Let's understand the working of this. And before we really get into the working of DAA instruction, let us understand what is the necessity of having such instruction. Okay. So suppose if you go to ATM machine, so let's say this is some ATM machine, and basically what you do is with debit card, you insert that debit card into ATM machine. You basically demand for some amount. Once you get that amount, there is a screen. You understand? There is a screen on which your final balance gets displayed. So let us understand what is the connection of this ATM machine example with this DAA instruction. Fine. So you understand that ATM machine is basically a computerized machine. So it is a computerized machine, meaning that whatever the operation takes place in ATM machine, those are automated processes. When I say it is a computerized machine, every computer by default works on hexadecimal numbers. Correct? So when it is basically working on hexadecimal numbers, definitely after working on these hexadecimal numbers, whatever result they come across are also hexadecimal results. Is that right? What if you basically insert your card in ATM machine, and let's say if you are checking for your balance, what if it displays your balance as ABCD hex? Will that be a good idea? Absolutely not. Please try to understand. Not only engineers like you who understands hexadecimal number system, but also a normal people who do not even understand hexadecimal numbers also go to ATM machines. So everybody should get the balance in by default in which number system? Of course in decimal number system. If your computers are operating on hexadecimal number system, it's your problem as an engineer. Okay, but a normal people should always get their balance in which decimal number, which number system. Basically it should be a decimal number system. Is that right? So even though your computer by default operates on hexadecimal numbers, generates results in hexadecimal form, but while displaying those numbers on the screen, there should be some mechanism that hexadecimal number system or hexadecimal results gets converted into what? Decimal results, and then only it should get displayed on the screen. I hope you understand that. And again, it again doesn't happen automatically. Converting those hexadecimal results into decimal is done by this instruction called as DAA instruction. But again, it is very important to understand its working, rather full form. It basically decimal adjust after addition. So this word is very important. It means this instruction will basically help you to convert your hexadecimal numbers into decimal results, provided you have done addition prior to this. Let me give you an example. Let's say if you do this 9 plus 1. So what is 9 plus 1? So you might say it is 10, but no. If every number is treated by computer as a hexadecimal number, 9 plus 1 will be A. Obviously, you never want this A to get displayed on the screen. Before that, what we do, once this addition is performed, we fire this instruction called as DAA, and DAA instruction somehow helps you to convert this A into a normal result, that is 10. And now as a user we get satisfied when 9 plus 1 is equal to 10. I hope you understand that. So DAA instruction is going to help us to do that. I'll take a number of examples, so you need not to worry about it. So let us understand some facts about DAA. The very first fact is DAA instruction by default operates on AL register, not even AH. It is always AL register only. The next fact is DAA instruction is written only after the addition is performed. Try to understand this last A alphabet in DAA instruction stands for what? Addition. So it is a rule that if you are firing this DAA instruction, before that some addition must be performed, so that it will help you to convert that hexadecimal result into decimal result. And how it is doing that? For that we need to understand the algorithm behind DAA instruction. So I'll explain you this algorithm first, and then to get the clarity on this algorithm we need to take certain examples. Let us see. So in algorithm there are steps. So what it does, after the addition is performed, if D0 to D3 of the result is what? Is greater than 9, or if auxiliary carry flag is equal to 1, then this instruction basically adds 6 with D0 to D3. I'm sure you will understand nothing out of it because I'm just reading the algorithm. Once I start with the example, I'll get back to algorithm and then you will have a clear connect. Right now let's read the algorithm only. The second step says, after addition, if D4 to D7 of the result is greater than 9, or if carry flag is equal to 1, then again it adds 6 with D4 to D7 of the result. Okay, so without wasting any time, let's take one example. I'll get back to this algorithm as I promised. Example number 1 is this 9 plus 1. So as a decimal number, if I treat 09 and 01 as decimal numbers, I expect that 10 should be the result. So 10 is basically the expected result, or the result that should basically gets displayed on the ATM machine, right? But the fact that by default every number by microprocessor or by computer are treated as hexadecimal numbers, am I right? So how it performs the addition? Look up. So this 09 will be treated as a hexadecimal number. So this 0 gets converted as what? 0, 0, 0, 0. This 9 is basically 1, 0, 0, 1. Plus, it should get added with 0. Again, we have 4 zeros here. And then we have 1. So we have 0, 0, 0, 1. Just for my reference, I am just putting here D0, D1, D2, D3. Then this is a D4, this is D5, D6 and D7, like that. Okay, now let me perform the addition. So what is 1 plus 1? It is 0, carry 1, then it is 1, then 0, 1, then we have 0, 0, 0, 0, right? So this is our result, this is actual result. Okay, now since every number is treated as hexadecimal number, naturally this is treated as 0 and this is treated as what? A. And what really gets displayed on the screen is 0A. Am I right? Then I told you DAA instruction basically helps to convert this 0A into 10, and let us see how it does. Before that, what I'll do is I'll just write a simple code to perform this. So first of all, I'll load 09 in AL register. Correct? Every number should be treated as hexadecimal, so I'm writing H here. Then we have, let's say, move BL, 01 hex. So I have loaded 09 and 01 are my first two numbers. I need to add them. So I need to write add AL, BL instruction. Am I right? So what happens after writing this add AL, BL? It adds AL with BL and answer gets stored in AL register. That is very important. And after this, we know that AL will have this result, that is 0A. After that, we write an instruction called as DAA, which stands for decimal adjust after addition. Let's see how it performs. Now, once the addition is performed, you check two things, that is D0 to D3 of the result. Just check it out. It is 1010. It means it is A. Can I say this is greater than 9? Okay. So I'll just go back to algorithm. Here it is clearly said that after addition, if D0 to D3 of the result is greater than what? Is greater than 9, or if auxiliary carry is 1. So right now our auxiliary carry is not set to 1, but yes, this condition is getting satisfied. Then we have to add 6 with D0 to D3. Okay. And also it is asking us to check D4 to D7 of the result, whether it is greater than 9. Let me just get back. You check it out. Your D4 to D7 is 0. it means definitely this is not greater than 9. Or they are also asking whether if carry is equal to 1, it means you know that the carry flag is set only when there is a carry generation from D7th bit. So again, it is not satisfied. So I'm not going for the second clause right now. So what I'm going to do is, since first criteria is satisfied, we need to add this 6 with D0 to D3. Let us see. So let me take my final result. It is 0 0 0 0 1 0 1 0. I need to add 6. 6 means what? 0 1 1 0. I need to add this 6 with D0 to D3. Okay, so 0 plus 0 is 0, 1 plus 1 is 0, carry is 1, 1 plus 1 0, carry is 1, 1 plus 1 0, carry is 1, and finally we have this result. Now look at this result. Check it out. This is 1, this is 0. Can I say this is the result that we were looking for? I mean, 9 plus 1 should be equal to what? 10. Now you are getting 10 as the expected result. But again, let me remind you, this is happening only after which instruction? DAA instruction, right? So to give you the more clarity, I'll take one more example very quickly. So here we have second example. Let me treat them as normal decimal numbers. What is 4 plus 2 is 6. What is 9 plus 8? It is 17. So 176 should be the result. Let us see in reality what do we get. So we know the fact that every number is treated as hexadecimal. So, let me treat them as hexadecimal numbers. So 9 is 1001, 4 is 0100, plus 8 is 1000, 2 is 0010. Let me just add them. 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 0 plus 0, 0. This is 1, 0, 0, 1 plus 1, 0, and carry is 1. Look at this, carry is 1. Okay, now let me check whether my D0 to D3 is greater than 9. Check it out. D0 to D3 is not greater than 9. Also, there is no auxiliary carry flag generated, right? So this is what my first step says. After addition, you have to check D0 to D3 whether it is greater than 9, or you have to check auxiliary carry is 1. So neither it is greater than 9 nor my auxiliary carry flag is set to 1. Let me check the second criteria. In second criteria, it asks us to check D4 to D7 whether it is greater than 9. Let's check. D4 to D7, if you see, it is 0001. It means this is 1, right? 0110, it means it is 6. See, D4 to D7 is also not greater than 9. It is 1 only. But can you see carry is generated here? Carry is generated. Check it out. The carry. If carry is 1, then it also asks us to add 6 with D4 to D7. Am I right? Okay. So before I go for DAA instruction, what I just wanted you to know that the result that we have received is 116, and the actual result should be 176. So since it is not matching, obviously it will not match, because you were anticipating that 94 and 82 are decimal numbers. So basically 176 is basically 176 to the base 10. But let me tell you, microprocessor is going to make believe that whatever numbers you fed to microprocessor for operations, they are going to treat that as a hexadecimal number, and that's the reason why you got result as 116. Since the result is not matching, and since my carry is equal to 1, according to DAA instruction, what we do, we add D4 to D7 with 6. So I'm going to add 6 here, right? So I'm going to add obviously nothing over here. So what happens? 0110 remains as it is. Now what is 1 plus 0? It is 1. Then this is 1, this is 1, this is 0. Am I right? And this 1 carry as it is. Check it out. What is the result? This is 7, this is 6, this is 1. Check it out. Your result is now matching with 176. I hope you understand that. Let me take one more example. Tell me, if I treat them as normal decimal numbers, what is 8 plus 6? It is 14, right? Carry 1, 1 plus 1, 2, 9 plus 2, 11. So 114 is the decimal result I expect. What happens when it actually treat them as hexadecimal numbers? Am I getting the same result or not? Let me see. Okay, so let me convert this 18. So what is 1? It is 0001. 8 is 1000 plus 9 is 1001. 6 is 0110. Let me add them. 0 plus 0 0, 0 plus 1 1, 1 1, 1 plus 1 0, carry 1. We have 1 like this. Now let me basically convert this into hexadecimal. So 1010 is basically A, and 1110 is what we get is E. So the actual result, so this is what? This is the expected result. And what is the actual result? Check it out. Actual result is something called as AE. Imagine you go to ATM machine and you don't get decimal number, and let's say you getting this AE to the base 16. So weird it is, right? So here again DAA instruction helps us out, right? Check it out. Here D0 to D3 is greater than 9. Also your D4 to D7 is also greater than 9. So you know that when D0 to D3 is greater than 9, you add 6 with D0 to D3. Also when D4 to D7 is also greater than 9, you have to add 6 with D4 to D7 as well. Let me write my result again. So my result was 1010 and 1110. I need to add 6 here also and 6 here also according to my algorithm, right? See, my algorithm says if D0 to D3 of result is greater than 9, add 6, and if D4 to D7 is also greater than 9, add 6 with D4 to D7. So I'm doing that. Let me add. So what do I get? 0. 1 plus 1 is 0, carry 1. Triple 1, sum 1, carry 1. Double 1, sum 0, carry 1. This is 1. 1 plus 1, 0, carry 1. 1 plus 1, sum 0, carry 1. 1 plus 1, sum 0, carry 1. Let me see what do I get here. Okay, so 0110 means 4. 0001 is 1. Carry is 1. Check it out. You're getting the result as 114, which is same as the expected one. I'm sure now you understood this DAA instruction. Would like to get some feedback from your end. Thank you.